Well, hope I'm up and running. I think it's recording. Quick shout out to Joy Bells. Pasang, Dreama, Tama, Chana, Colonel Singh, Joy. Can't wait to see you all. I hear some of you are preparing for an entrance exam, so I'm glad to see you're doing some math too. All right, back to getting this uploaded to everybody. So got to make the video. This is about shortcuts. You got a big test, you've got to be doing 2-hour test. It's about 100 problems, so you're going to have to know your stuff. And it's nice if you take a little deeper dive into some things. That extra little bit of time sometimes pays handsomely. And let's give a shout out to Baba G, because on every single one of our tests it says, effortless effort takes effort. And I think that's very true. And when I heard that, I said, wow, I'm going to use that every test. And I've been doing it now for over 10 years, and it's still true. All right, so let's talk about a shortcut. So x plus 3 squared, most of you, not all of you, but some of you are still multiplying that out. And correctly, getting x squared plus 6x plus 9. But what happens if we just did it without having to write parentheses times parentheses? Can we see how to get an answer like that from this process? What do we see? What do we notice? We notice that I forgot to get a good marker. Haven't done any videos in a little while. Let's see if this works. Oh, this is a beauty. Well, what I'm seeing is a connection at the beginning and at the end. Seems easy enough to see. And I'm also seeing that 3 times x gives me half of that. So I suppose if I doubled it, I'd be home free. All right, can we use it now here? You pause the video and I'll just keep going. You pause the video. I'm hoping when you unpause, you say x squared minus 8x plus 6. Because that allows you to go to the next problem quickly. You don't have to put anything down. You don't have to show me all the work. In fact, I don't want to see all the work. I want to be able to see that from you without writing parentheses times parentheses. It's easier to correct. All right, so how can we use that? Well, here's a typical problem. Giving you the answer to a quadratic. Ax squared plus bx plus c equals 0. That's the answer. All right, so what are the steps that bring us back to the original question? Well, we got to get 0 on the right side. That's where we're headed. So we're going to move everything to the left. First thing we move is the 5. Then I think from the last problem, we shouldn't have to do this. We should be able to square that in our head, write it. We should be able to square plus minus, gets us positive. 3 squared, I squared, and know that that's negative 9. We're at that stage of the semester. And so negative 9 comes over, it gives us 34. So the question is, could we have written this answer without even doing any of the work? Well, here's the answer. You pause the video and see if you can, I'm going to give you a little longer pause than usual because I don't have my science card. And I am going to go get it. Maybe take a look at that. And I am 30 seconds away. Obviously was ill prepared here. It's short on time, but I wanted to get this up and running. And here comes the trusty science card making its way. So I apologize for that amount of time lost on continuing the video, which makes it longer. Okay, so be able to see what's going on. Well, I can certainly see that from 5 to 10 is a doubling process. And addition appears to become subtraction. Well, that makes sense because it's going to the other side. Right? We already talked about this being squared, which is 9, and that actually gets squared, which is 25. Geez, I think 9 and 25 is 30. So you try that one. Let's see if you can write the answer. Pause the video. Keep going. I'm seeing x squared plus 12x. 36 and 4 is 40. That's what I'm seeing. That's what I would write and just continue on. When I start putting the work down, I get tired. I make careless errors. Yes, if you know what it is, just write the answer. All right, so let's make sure x plus 6 squared minus 36 plus 40 equals 0. Okay, so that's positive 4 on this side, which means it's negative 4 on that side, plus minus. Gives us the 2i. Yeah, and yeah, it looks good to me. All right, now what happens if it's not imaginary and it's something like x plus 5 plus or minus root 3? Well, we don't have I squared over here. Okay, so when I square that, it's going to be positive. And when I move it over, it's going to be negative. So see if you can just write the answer. I just keep going. X squared minus 10x, 25 minus 3, 22. So it should be plus 22. Let's figure out if that's true. So that gets us x minus 5 squared minus 25 plus 22 equals 0. That's negative 3 becomes positive 3, which becomes plus minus the square root of 3, and negative 5 becomes positive 5. Whoopee. Just write the answer. All right, now where can we use this squaring process and finding the center and radius of a circle? Right, now, there's lots of videos on the channel that practice this and show all the steps. But we're at that stage of the semester where if you know how to do it, you get it right. Why not simplify the process just to writing the answer? All right, step 1. We know we got a parentheses and x minus 5. We're cutting that in half. Well, that means that 5 is the center of the circle, because that's what makes a 0, and 0 squared is a minimum. Over here, we have y plus 2, when we cut that in half. Okay, so negative 2 is the center. All right, and of course, you've got squares coming that move to the other side. When you square something, it's going to become a positive on the other side. It's negative here, right? So what do we square? 25 and 4 is 29. 29 and 20 is 49, right? So the radius is 7. Let's do it out and make sure. So we got a square, we got a minus 25, and then leave myself enough room. See, it's taking me time now to have to do this. Y plus 2 squared minus 4 equals 20. Okay, so there's our x minus 5 squared plus y plus 2 squared. We could make a mistake now. 49. All right, so what do we have? We got x minus 5 as one side of this triangle. We got y plus 2, and we got 7 right there. And of course, as this one gets longer, this one has to get shorter because the square areas have to equal 49. Did I give you one to try? Well, let's give you one to try. All right, let's try, how about we try, x squared plus, let's go 12x plus y squared minus 6y. Let me give you something nice now. 36 and 9 is 45. So let's go with 45, and what's the next? We're 64, right? So that's 19. All right, so you find the center and the radius of that. Pause the video, just tell you what it is. So positive 6, so negative 6 is the center. Y minus 3, so positive 3 is the y value of the center. 36 and 9 is 45. 45 and 10 is 55, and 9 is 64. So therefore, the square root of 64 is your radius, 8. Now you can take the time. I guess I will. So x plus 6 squared minus 36 plus y minus 3 squared. Did I make a mistake? No, good. Minus 9 equals, what was it, 19? And I think that takes us right back to x plus 6 squared plus y minus 3 squared equals 64. Okay. Okay, well, that's what, if you keep your eyes open, you can do. Just write your answer. That's about a 10-second problem, maybe 15. All right, students in calculus have trouble integrating something like this, which is a shame. If you get good practice here, you know how do you get from negative 3 to 4? You got to go up 7. So that's just the kind of the FOILing process for that. And I got minus 21. How do I get from minus 21 to minus 11? I add 10 over x minus 3. You don't need the long division for problems like that. This is really good practice for you. I hope you do it. And if you want to make sure if you're right, throw a 3 in here. And if I did it too quickly and I made a mistake, then it doesn't come out as positive 10, something's wrong. 9 and 12 minus 11. 12 minus 11 is 1. 9 plus 1 is 10. I move on. Now, for those of you who are having to show long division, which then, if you do a lot of it, turns into synthetic division, always shortcuts, the more times you do a problem. You gotta maybe, this method is a little quicker for you. So long division is there when you can't keep the numbers in your head. Started getting a little too complicated. So you go to writing things down. So what I like to do instead of the textbook method of subtraction is adding an opposite column by column. So x times x is x squared, which is positive. I make it negative, and I add. Now, you probably can see the synthetic division. You don't have to do that. Well, I'm not going there. I don't teach synthetic division anymore. Minus 3x is that column. X times minus 3. Remember what we're doing. We're trying to get here, which was off the screen. We're trying to get something times something that gives us x squared plus 4x. I changed this to minus 11 over there for a reason. I don't remember what it was, but I changed it. So we're getting back to this problem now. All right, so what did I say you do? Subtracting means you're really adding the opposite. Okay, so I'm going to change the sign and add. That gives me 7x minus 11. X goes into 7x 7 times. 7 times x is 7x. I change the sign and add. 7 times negative 3 is negative 21. I change the sign and add. There's our remainder of 10. All right, so standard form of a line. We're getting this on every test the rest of the semester. Write the perpendicular through the coordinate high there. All right, so let's take the long route. Minus 7y, bring the 5x to the other side, divide by minus 7. 5/7 is the original slope. So if you had to find a parallel slope, it's also 5 over 7. Okay? What's the perpendicular? Well, the perpendicular, we can look at a 5 over 7 rate. We can draw a perpendicular. We can do the measuring, and it turns out the perpendicular is minus 7 over 5. Okay, and we're going to try to go through high there, so let's get there. I gets me there. Okay, now let's erase and let's look at the answer. Minus 7 over 5 parentheses, ha 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 ha. Geez, I wonder how I can get the perpendicular without doing any work. Why don't you try one? Why don't you try 3x plus 4y equals ha ha. Constant doesn't matter, does it? Rate of change is the interplay. And let's go through about negative 4, 7. Okay, so I'll write that part right now. X plus 7. Okay, and can you tell me the perpendicular? Geez, I hope you say 4 over 3 without doing any work. That is, if you understand this process and if you've been getting it right for the past 10 tests, then jump to the chase. Whatever that means. So if we know the perpendicular from standard form, I guess the original is the negative reciprocal. Now for this problem, then I suppose, you would divide, right? To get y alone, there's a division. So that's always going to be in the denominator. And if you take the opposite of that, then you kind of know the original slope too. So what's the slope of ax plus by equals c? I know b is in the denominator, and I change a. Just diving into it a little deeper, just putting that little extra effort in. Oh, it's going to save so much time over the long run. Sketching, putting it in graphing form. No, don't. Just sketch what you see. We've looked at this a lot. If you really put your mind to it, you can tell what the rate of change is at the y-intercept. All right, so we know what? We know that it's cup shape up because that's positive. And I also know I'm on the upside, right there, at 0, negative 5. And this explains it. Pause the video and look at it. The new numbers are there, and if you want to understand derivatives, you want to understand what Newton saw, starts here, okay? And it ends here with a drawing. Yeah, I just did an x there and an x there, and the root of the x squared is 2x. Okay, so there's lots out there that you can look at to make sense of what I just said. But if I know that that is the y-intercept on the increasing side, then I know my x value is negative, so I don't have to worry about plus and minus b over 2. All I got to do is divide 2 into 16, which is 8, and cut it in half, and remember which side I'm on. And then if I put negative 4 in, that's negative 64, and the shortcut is to cut it in half. All right, and so I get minus 37. That's graphed. What's the graphing form? Well, you take the 2 and you make a 0 out of the -4. Then you got it in graphing form. What are the roots? Well, you got to move 37 to the other side. You got to do the plus minus square root. And you got to divide by, where was it? By 2. And you got to move from -4. That'll get us our roots. And there are lots of videos, which I got to organize at some point from Algebra 1 to Calculus. That's the next major product. Oh, I got to give you one to try. All right, so back with a science card. Next time I'll remember to have it handy. All right, so let me give you one to try. Let's go with, how about y equals minus 3x squared plus 30x minus 9. Okay, so you pause the video and see if you can come up with the sketch and the roots in under a minute. And I'll get some space here and I'll just do it. I see cup shape down. I'm on the increasing side. Therefore, 0 gets me -9. I therefore know I have a positive x value. 3 into 30, 10. I cut it in half. 5 is the magic number. 5 times 30 is 150. Cut in half to 75 minus 9 is 66, I believe. I hope I didn't make a mistake. Let's check it. It's 75. 5 squared is 25. If I divide, yes, I'm getting the ratio I want. So when do I hit a height of 0, which is the x-axis? Well, I got to go down 66 units, but I'm dividing by -3. So I got some real roots. I can see them. So I really wouldn't have had to do that. All I got to do is 66 divided by 3, plus minus. And where am I measuring from? From 5. And I got to remember to square root that. I got the roots. So let's check and see if that's really true with what we did before, because I've done it with this type of problem. So I'm going to go x minus 5 equals plus minus the square root of 66 over 3. I'm going to square this, x squared minus 10x plus 25. I'm going to square this, and I get 66 over 3. I'm going to triple this, which is 3x squared minus 30x plus 75. And I'm going to take away 60 and 66. And did I make a careless error? It looks like I did somewhere. Looks like I made a careless error here, because that should be -9, not +9. So this happens sometimes. I'm not going to make the video again. So where did I go wrong? You try to find it too. Okay, so from 66 to, oh, I was going to a height of, no, I'm getting back to x squared plus bx plus c form. This is right. This is not. So that's +3. I made a mistake here. Oh, I made a mistake because this originally was minus. So if I make that -3, this becomes -75, and then this becomes +66, and I just learned something. Yes, doing that helped me. All right. That's part of math. Make a mistake, go find it, and try not to make it again. All right, sketching. So what do I know? I know I got y equals 9, and I know my first jump is going to be 5, and my second jump is going to be 10. So therefore, I wouldn't have to write those. I could go right here and go 14, and I could go right here and go 19, and I could erase this stuff, and I could go dot. So let's get that over here. Let's get 19 over here. Let's put a dot there. And I know I've got a general shape like that. Now the question is, what x's go with it? Well, I got to know something. Got to know something about exponentiation, which has something to do with closing that door. Okay. The only way I can get 14 is to say 5 plus 9. So my exponentiation has to get me the number 1. So what exponent do you put on top of b to get 1? My God, I hope you said 0. So that tells me to make the x be at this equal to 0. That's not hard. That's 8. Let's get that comma in a better place. Okay? And isn't it fairly easy to multiply by 2? And how am I going to make this the number 2? Well, I hope you say make the exponent 1. I got news for you. If you make the exponent 0 and you make the exponent 1, that's your first jump, that's your second jump, every single time from the constant. And I'll give you a chance to do one in a moment. All right, then you should be able to go forwards and backwards with this. So where am I? Did I say what I wanted to say? I hope so. All right, so let's try one more. Yeah, let's try one more. Let's try 6 plus, how about we go 8? Let's cut it in half. Let's go to x minus 1973. All right, and you try to graph that right now. Pause the video. I'm just going to do it. I see y equals 6. I'm going to jump 8. That takes me to 14. I'm going to jump half of 8, which is 4. That's going to take me to 10. So I got exponential decay. Okay. What goes with 14? Making a 0. So that's 1900. Gets me 8 and 6, 14. And what gets me 10? 73 years later, 1973. Gets me 4, I said. 4 plus 6 is 10. Yeah, I'm done. I move on. Yep, almost done here. A few more problems to look at. Trying to save you time here. Little extra effort here. Trying to save you time. And you get to practice these next day in class. You go look for them. And then you can practice them the next day after that too. And then you get tested again. And you get tested about 6 more times. So, conjugate. We know 5 minus 2i, 5 minus 2i. All right, so we're at that stage. All right, so let's do it out. 3 times 5, then we're going to look at the answer and see if we can take a shortcut somewhere. 3 times 5 is 15. 3 times minus 2i, minus 6i, minus 20i. I suggest you be careful with this because at this stage, you're not getting a little tired. 5 times 5, 25, minus 4i squared. I'm not going to do this out, plus minus. The middle terms cancel. So what does the denominator become? 25 plus 4. What have I got here? Did I do a new problem? And I have the old problem up? Yeah, that's not what I started with, is it? No, I was trying to keep the numbers smaller for you. So we started with this problem. 3 minus 4i over 5 plus 2i. That's the one we started. That's the one we're doing right now. And it takes us to here. Okay? And positive 8 becomes what? A sign change. So I take 8 away from 15 and I get 7 minus 26i. Then we erase the word. And we see 29. Is there some way that I can work with the number 5 and the number 2 to get 29? Yeah, square root. All right, so let's see if you can tell me what the denominator of this is. I got a 5 and a 6i. I hope you're saying 25 plus 36 without having to write 5 minus 6i. It's only a small shortcut. But if you're having trouble finishing the test, then you should only write the numerator and just nail that immediately. And you still have to do this one. And every time you do it, get a little better, a little faster, a little stronger. All right, so high school math, things I think you absolutely need to know. You need to know that 0 squared equals 0 as a minimum. Okay, if you can square something to get smaller than 0, please write to me. Not imaginaries, real numbers now. Square root of 0 is 0. Well, the square area is 0. The smallest it can get is a square root. That is 0. All right, this area is smaller than that. That area is smaller than that. Get into calculus with that concept. B to the 0 is 1. Absolutely need to know it. Okay, that there's no difference in factors. If you got 3 in the numerator and you got 3 in the denominator, that's b to the 3 minus 3, which is 0, and something divided by itself is 1. So that's essential. I think if you don't know these values for e, you're doing yourself a disservice. Memorizing these values will help you with your rules of logarithms, solving e to the x and ln of x, compound interest and everything else. I implore you to know those. Pause the video. I've given a handout, but if you're not part of the class and you're tagging on, take the time to do that, right? Because it's going to allow us, just like we did sketching, well, I'll do one right now. So let me do an e to the x graph, show you how similar it is to the other. And what we're going to use, we're going to standardize 1/3, we're going to standardize 3. I'm going to do the one over here. So 5e to the x plus 7 over 3 plus 2. All right, so that's exponential growth. My first jump is 5. My next jump is 15. 3 times that. That's the shape, provided I use the correct exponents. Now, how do I get a 5 plus 2? I need a 1. 5 plus 2, sorry, 5 plus 2, right? I need e to the something to get me 1. God, I hope you're saying -7 gets the job done. Because that makes e to the 0, and anything to the 0 is 1. Essential to know that. All right, so therefore, -7 is going to get me 2 plus 5 +7. And now what's going to get me 15? I got to multiply by 3. And if you know that e to the 1.1 gets you multiplication by 3, then all you got to do is set this thing to 1.1. Let me write it higher here. Let me do it over here. X plus 7 divided by 3 equals 1.1. I hope you're saying 3.3 first, and hope you take 7 away, which is the same as the opposite of 7 minus 3.3, which I believe is 3.7. So this thing is equal to -3.7. And that's going to get me that jump. I hadn't anticipated talking about that, but what you learn in one place, you can always use in another. All right, and there's plenty of practice on the YouTube channel. So if you want to learn how to graph e to the x quickly and easily, go to rapid fire graphing e to the x. Graphing e to the x. There's a lot of practice there. All right, so those exponentials you need to know. You also need to know, as we're starting to get into trig, that the cosine of 0 is really about the width. And 0 is, how far are you running around the circle? Hopefully you say 6.28 radius lengths to get around once. That's another discussion. So you need to know what this width is at no trip around the circle, circumference, and hope you're saying 1. And you need to know what the height is here. Remember, heights go up to what? 1. Heights go to -1. So hope you know that the sine of 0 is 0. Because all the constructions we're doing, all the conversion constructions are based on 0s and 1s. What's 59.87772 multiplied by 1? 59.87772. It's 59.8772 times 20. 23, 23.8. I don't know. What's 59.782? I don't even remember what I said. Times 0. I can tell you the answer. It's 0. Very useful in conversion. So, flip q pi over 2. Can you tell me what the height and width are? Can't even draw the triangle, can I? No. So if you said the cosine of 0 is 1, and the sine is, I'm sorry, cosine of 0 is 0, there's no width, and the sine of 0 is 1, you'd be right. Helpful to know. How about over on this side of the circle? Can we draw a triangle, which we can't draw? I'm over at pi, 3.14 radius lengths. I'll write that because I think it benefits you. All right, so what do we have? What's the width? I hope you say -1. Right, and there's your cosine curve, right? Where's pi? It's right there, -1. And what are we doing? The widths aren't changing much, are they? Because I move that length. That width isn't changing much. I got news for you. Tangent at that location is pretty flat for a reason. All right, so pi, -1, what's the height? Well, you said 0, because it's in the middle again. How about this location? What's that location? Sine of pi over 2. Now, I don't think my heights are changing from here to here much as I draw triangles. I don't think my heights are changing. If you look at the sine function, at 3 pi over 2, and 3 pi over 2 is here. Oh, it's flat again. Oh, okay. So what is the width? Well, the width is right there, and I don't see it. So the cosine of 3 pi over 2, hope you're saying 0. And the sine of 3 pi over 2, hoping you're saying -1. We're going to work with those numbers. All right, and we'll keep working with them because why? Because repetition is our friend. Here's the other quote I put on every test. And that comes from Mark Deaver, who's a Tai Chi master. You know, Tai Chi. Wife wanted me to study Tai Chi because I'm not walking too well anymore. All right, I thought it was a brilliant statement on his part. Math's no different. The more reps you get, the more practice you get, the more conversations you have, the more you're going to know and the more you're going to be able to do. So, where the heck am I? I'm over here. I'm looking at shortcuts again. But you also need to know these values up here, right? Otherwise, you're working blinded. You got to know what √2/2 is. It's about 0.71. √2/2 is also the square root of a half. Be nice if you knew that. You know, you can say that to yourself 5 days in a row, and then if you see it somewhere in a class, you're probably going to work with it properly. Square root of 3/2, roughly 0.87, close enough for us, which is smaller than 1, by the way. So this length, the hypotenuse is opposite the 90. That's got to be the biggest. Does it look like 0.87 is slightly smaller than that? Hope so. And what would happen if I doubled the size of this triangle? Angle's the same. 1/2 becomes 1. That becomes 2. That becomes 2's cancel. √3. And I think you need to know what √3 is. It's actually twice that, but I'm calling it 1.73 because that's actually a little closer. It's nice to know that. Now, why am I giving you this triangle? Because you're starting to work with the tangent function. Now you don't have to work with fractions. So what's the tangent of 30 degrees? 1/√3. What's the tangent of 60 degrees? Well, that's opposite the 60 degree. √3/1, which is √3. And that's what we're going to be working with the last month of the semester. When we draw a tangent, we're going to double the size of the units triangles drawn. All right, so √2, approximately 1.41. And √3, we just did, I think, well, maybe not 1.73. Oh, yeah, I did. Okay, so I threw a lot at you quickly, but, you know, you want to be able to work with conviction and some competence, and that takes practice. When the brain gets tired, it's very easy to make careless mistakes. So there's a fine line behind doing things too quickly. I mean, everything comes from soccer, right? You can't play quicker than your skill level. But try to get your skill level up and you can play more quickly. Well, that's almost worth writing on the top of the test. But I can't even remember what I just said. All right, so that's that. And I hope that you come back rested and ready to do some serious practice Wednesday and Thursday. All right, shout out to Joy Bells again. Coming soon to a theater near you. Bye-bye.